Welcome back to it. It's Maths Masterclass with Leo. I am Leonard, and today we are doing a logarithmic differentiation. Differentiating logarithmics. Logarithmic differentiation. So today we are dealing with logs and lean. Okay. So now, before we start with logarithmic differentiation, we need to know the laws of log, right? We must know all the laws of log. First law being, when you have log of A multiplied by B, this is similar to log of A plus log of B, right? Number two, when you have log of A divided by B, this is similar to log of A minus log of B. Number three, when you have a log of A to the power n, this is similar to n log of A, right? Then we come to lean. So in calculus, we're going to deal more with lean than log. We're going to differentiate more of lean than log. So they are also similar to logs. The laws of lean are also similar to log, right? So this is presented by an Aperian logarithms. Wherein he says, similar to your log, if you have number one, lean of f of x multiplied by g of x, this is similar to lean of f of x plus lean of g of x, right? And he's coming back to say, number two, if you have lean of f of x divided by g of x, this is similar to lean of f of x minus lean of g of x. Thirdly, lean of g of x to the power n. This is similar to n lean of g of x, right? And then, say you're given something like y is equals to f of x multiplied by g of x divided by h of x. You're given something like this. Before you differentiate this, you can just introduce lean to make it simpler. Lean of y is equals to lean of f of x multiply g of x divided by h of x. Right? In a simplest term, this can be written as lean of y is equals to lean of f of x plus lean of g of x minus lean of h of x. Right? Then from there, say you're given a simple equation to say differentiate d over dx of lean of x. How do you differentiate that? Differentiating lean with respect to x. Remember when we differentiate lean, we said lean of f of x. Differentiating this is similar to saying lean or f prime of x divided by f of x. This is how you're going to differentiate your lean. So you're going to do the same thing here. We are going to differentiate our x. Differentiating x, we get 1. Then rewrite our function, which is x. This is our solution when we are differentiating d over dx of ln of x. Right? Say you're given a question, let's say y is equals to ln of 3x squared plus 2x minus 1. They want you to differentiate this. They want you to differentiate this. Differentiating this, you will have dy over dx. This is equals to, I'm going to differentiate my function. Differentiating 3x squared, I'm going to get 6x. Differentiating 2x, I'm going to get plus 2. Divide by my function, which is 3x squared plus 2x minus 1. That is how I'm going to deal with that. That is how I'm going to deal with differentiating that. Let's get one more question. Say you are given y is equals to ln of sine 3x. They want you to differentiate that. Differentiating this, I'm going to get dy over dx. This is equivalent to, I'm going to differentiate what's inside my bracket, which will give me 3 cos of 3x divided by my original function, which is sine of 3x. Then this represents cot. This is the inverse of tan, which is cot. 3 cot of 3x. That is my dy over dx. Let's move to the next page. Now, you're given dy over dx of y. Differentiate this. Okay, let's say ln y. Ln y. Differentiate this with respect to x. How are we going to do that? So this will mean when I differentiate y, I'm going to get 1 divided by the original function, which is y. Then, because I'm differentiating with respect to x, this is going to be dy over dx. Implicit differentiation. Implicit differentiation. Okay? Say you're given something like y is equals to into 1 plus x squared square root into x minus 1 divide x square root of x plus 2. X plus 2. Okay, they want you to differentiate this, right? So differentiating this, you're going to introduce your ln. Both sides, ln of y is equals to ln of into 1 plus x squared square root into x minus 1 divide x square root x plus 2. Right? Then from there, this is similar to ln y is equals to ln of into 1 plus x squared plus ln of into square root x minus 1 minus into ln x plus ln square root x plus 2. Then ln of y is equals to, because of this squared, it means I'm allowed to say 2 ln of 1 plus x plus, I can change this to ln of x minus 1 to the power half minus into ln of x plus ln of x plus 2 to the power half. Now I'm going to start differentiating. Differentiating ln of y, this will give me 1 over y multiply dy over dx. This is equals to, okay, differentiating 2 ln of 1 plus x, I'm going to get 2 into 1 over 1 plus x. Then plus, this one is going to be 1 over 2 into differentiating x minus 1. This will mean I have 1 over x minus 1. Then minus differentiating ln of x, I'm going to get 1 over x. Minus differentiating this one, I'm going to have 1 over 2 into 1 divided by x plus 2. Then from there, 1 over y multiply dy over dx. This is 2 over 1 plus x plus 1 over 2 into x minus 1 minus 1 over x minus 1 over 2 into x plus 2. Then remove this y from this side. I'm going to have to multiply by y both sides. Multiply by y. And this is similar to dy over dx is equals to y into 2 over 1 plus x plus 1 over 2 into x minus 1 minus 1 over x minus 1 over 2 into x plus 2. But I know what is x. I know what is this y. I'm going to substitute that y. The original function that I was given, which is, in this case, into 1 plus x squared square root x minus 1 divide x square root into x plus 2 into 2 over 1 plus x plus 1 over 2 into x minus 1 minus 1 over x minus 1 over 2 into x plus 2. That is my solution for this question. That is my solution for this type of a question. When I differentiate this type of a question, this is what I'm going to get. Right? Okay. Let's move. Let's say now they want you to differentiate. Let's get a different color. They want you to differentiate f of x to the power x. How do you deal with such questions? For example, they can ask you y is equals to x to the power x. They say differentiate this. This is where ln comes in handy, because you'll say introduce ln both sides. This will be ln of y is equals to x to the power x, okay, or ln of x to the power x, ln of x to the power x, right? Then from there, according to ln, or the third law of ln, I'm allowed to say ln of y is equals to x ln of x. Then from this, that's when I can now differentiate ln of y with respect to x. This will give me 1 over y multiply dy over dx. This is equals to, now I can see that this is a product. I'm going to keep this constant, which is x, differentiate this, I'm going to get 1 over ln, 1 over x, plus keep this constant, which is ln of x, multiply by 1. And then all in all, this will give me x over x plus ln of x, which this is equals to 1 plus ln of x. Not forgetting that you still have 1 over y multiplied by dy over dx. This side, 1 over y multiplied dy over dx. From there, I'm going to remove this y, which means I'm going to cross multiply by y over 1. This side as well, multiply by y over 1. Meaning I'm going to have dy over dx. This is equals to y into 1 plus ln of x. From there, I can now say this, dy over dx is equals to, what is this y? Y is that, x to the power x. So this is x to the power x into 1 plus ln of x. That is how you deal with this question. Let's get another one. Say you're given now, you are given y is equals to into x plus 2 to the power x, right? Apply the same thing, both sides, introduce ln. Ln of y will be equals to ln of into x plus 2 to the power x. Then from there, according to the laws of ln, or the third law of ln, I can do this. Ln of y is equals to x ln of x plus 2. Differentiating this, I'm going to get 1 over y multiply dy over dx. This is equals to, I can keep this one constant, which is x. Differentiate this, I'm going to get 1 over x plus 2. Then, differentiate this and keep this constant. It means I'm going to have plus ln of x plus 2 multiplied by 1. Because when I differentiate x, I'm going to get 1. Then from there, 1 over y is multiplied by dy is equal, dy over dx is equals to x over x plus 2 plus ln of x plus 2. From there, remove this y, means I'm going to cross multiply by y over 1. This side as well, cross multiply by y over 1. Then dy over dx is equals to y into x over x plus 2 plus ln of x plus 2. From there, dy over dx, this is equals to, what is my y? My y was given as x plus 2 to the power x into x divided by x plus 2 plus ln of x plus 2. That is my solution for this type of a question. That is my final solution for this type of a question. Okay, let's get one last question, which is given as y is equals to x to the power 3x plus 2. 3x plus 2. So in this case, they want us to differentiate this. Now you know that you'll introduce ln of y is equals to ln of x to the power 3x plus 2. Right? Then third law says I'm allowed to say ln of y is equals to 3x plus 2 ln of x. From there, differentiating 1 over y multiply dy over dx. This is equals to, I'm going to keep this constant, which is 3x plus 2. Differentiate this, I'm going to get into 1 over x. Then differentiate this, keep this constant, I'm going to have plus ln of x multiply by 3. Then 1 over y multiply dy over dx is equals to 3x plus 2 divided by x plus ln, or plus 3 ln of x, 3 ln of x, and then cross multiply by y over 1, cross multiply by y over 1. This and that, they cancel. I have my dy over dx is equals to into, okay, is equals to y into 3x plus 2 divided by x plus 3 ln of x. Then from there, this will mean x to the power 3x plus 2 into 3x plus 2 divided by x plus 3 ln of x is my solution when I differentiate y is equals to x to the power 3x plus 2. Thank you for tuning in. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango!